So today for our notes, we're looking at section 214 in Algebra 2. Let's put it all together. So we're looking at the whole chapter. We're looking at putting this graphing together with factoring and the remainder theorem. We're kind of looking at everything. So we know that negative 7, 0 is an x-intercept. So that means that x plus 7 is a factor. And if we get stuck, this is my x value. I have an x equals negative 7. If I add 7 on both sides, I have x plus 7 equals 0, and it equals 0 because it is a factor. So x plus 7 is a factor. Use the backwards box method to factor f of x, fill out the information, and draw a rough sketch. So x7, let's look at factoring this. We have an x cubed right here. X divides into x cubed, x squared times 7 is 7x squared. So that is already what we want. So I need to put a 0 right here, which means we have a 0 up here, which means 0 times 7 is going to be 0x. This would be like my x term right here. So let's see. That means this needs to be a negative 9x. 0x plus negative 9x would be a negative 9x. So negative 9 times 7 is negative 63, which equals my remainder. So check, or sorry, equals my constant term. So I don't have a remainder. So when I divide this out, I get x squared minus 9. So if I have x squared minus 9, I would keep factoring to be x plus 3 times x minus 3. If I think about that being set equal to 0, then if I keep solving, I get an x-intercept of negative 3, a 0 of negative 3, and a 0 that's positive 3. So as intercepts, though, I want to write them comma 0. So my zeros are x-intercepts. Let's write x-intercepts. X-intercepts are going to be negative 7, 0, negative 3, 0, and 3, 0. All of these factors are to the first power. So that means we're going to cross at all of them. There's no like square up here in the corner that would make it bounce. My y-intercept, I could get, it's my constant term of the original. So if I put in f of 0, I have 0 cubed plus 7 times 0 squared minus 9 times 0 minus 63. All of the zeros out, we just end up with negative 63, which is my constant term in the original. So that's 0 comma negative 63. My leading term was x cubed. So that means I have cubic, I have third degree, and it's positive, which means this is my graph shape. And because that's my graph shape, my left-hand arrow is pointing down, so negative infinity. My right-hand arrow is pointing up, so positive infinity. And now I want to go ahead and graph. 1, 2, 3, negative 3, 4, 5, 6, 7, and 1, 2, 3. So those are all my x-intercepts. My y-intercept is negative 63. I'm just going to pretend this is negative 63 down here. And then I know I need to connect with the right graph shape. When I connect these, I don't know exactly how high or how low those peaks and valleys go, but it is just fine, right? We're giving it our best guess. So this is kind of the heart of what we're doing today. So I'm doing the graphing, but first I have to do all of the factoring part. So they're not giving me a graph to do where I have the function in factored form. On the next one, I know x of 2 equals 0. So that means I have a factor of x minus 2. So remember, this is like x equals 2. To make my factor, I would subtract 2 on both sides. X minus 2 is equal to 0. So factor of x minus 2. You could do synthetic to divide this out. You could do box. You could do long division. So x divides into 3x cubed. 3x squared times, this is going to be negative 6x squared. I have to get a negative 2x squared for my x squared parts though, so this one's going to be 4x squared. X divides into 4x squared, 4x times negative 8x This would be negative 4x because these two, negative 8, negative 4, have to make a negative 12. So this is negative 4. Negative 4 times negative 2 is positive 8. So I have a note here to pretend that this is 8. Otherwise, it doesn't work. So let's use 8. So if it's 8, it magically factors. Now we're having to factor 3x squared plus 4x plus 4. Or sorry, minus 4. So for that, I'm going to use a box again. So go ahead and create your little box. I have 3x squared, negative 4. So my magic number is 3 times negative 4, which is negative 12. So I'm looking for things that multiply to make negative 12, add to make a positive 4 up here. That's going to be 6 times negative 2. So 6x, negative 2x. You could certainly swap those around. Look in your rows and columns for what's in common. X, 2, 3x, negative 2. And then we'll go ahead and factor. And then when I switch to my next page, it means my zeros would be, let's see, 2 comma 0. I'm writing x-intercepts. This 3x minus 2. If I have to go through and solve it. And that would be 2/3 0. The next one, x plus 2, is a negative 2, 0. All of these factors are first degree. I don't have any factors being squared or anything. So cross, cross, cross. My y-intercept, remember, is my constant term of the original, which is a plus 8. So that's going to be 0, 8. My leading term was 3x cubed, so degree 3 positive, which means this is my graph shape. So again, my left arrow is pointing down, negative infinity. Right arrow pointing up, positive infinity. So let's go ahead and graph. So 2/3 I'm going to plot right here. Negative 2, 2. Okay. And I know what my graph shape should look like again. Oh, I've got to have that positive 8 up here somewhere. So it's going to look something like this. It could be 8 as like a maximum. It might not be, right? It might go above that or something, and I don't really know. All right, here's another one. G of x equals 16x cubed minus 44x squared minus 42x. And it asks me to factor. First, I would want to factor out the greatest common factor. So let's factor a 2x out of everything first. I think 2 is the biggest number that divides into all of those. That would give me an 8x squared minus, let's see, 44 divided by 2 would be 22x minus, the x is gone, 42 divided by 2 is 21. So really, I know now this is going to be 2x times 4x plus 3 times something. So let's go ahead and put this in a box. Really, I could just do kind of my normal factoring here. I'm not sure what the best way to do this is, but it's going to just kind of be my normal box, right? So this would be an 8x squared. This is going to be a 4x and a 3. So this is going to be 2x, because 2x times 4x would be 8x squared. This one's going to be 6x. I know this has to be a negative 21. And I know my diagonal has to be the negative 22x. So that would be 6x minus 28x. Right, 6 minus 28 would be a negative 22. And then this would be a minus 7. So it factors to 2x times x plus 3 times 2x minus 7. All of my factors are first power again. Remember, when we're finding our zeros, it's like we are solving for x, like I'm putting a 0 in here, and I'm doing zero product property. That's what it means when I'm finding an x-intercept. I'm letting my y equal 0. This one's a little bit trickier, so I'm going to show some work on it. I don't know why I wrote a 3 instead of a 7. So divide by 2. So I either have, so I've got 0. So that's going to be 0, 0. Subtract 3 and divide by 4. So I've got a negative 3/4, comma 0. Here add 7, then divide by 2. So 7/2, comma 0. And this was a lot of work. My y-intercept, oh, and it crosses out all of these. I don't have any factors that are squared or anything. My y-intercept is also 0, 0. So if I put a 0 in back in the beginning for x, all of that would 0 out. My leading term is 16x cubed, so that's going to be degree 3. Positive again, same kind of shape, same kind of end behavior we've had. And now we need to try graphing. So let's go ahead and make our point, 0, 0. 7/2 is like a 3.5. Negative 3/4 would be pretty close to the negative 1. And so now we're going to go ahead and make that same kind of graph shape. All right, looks great. Last one's pretty tough. If 1 and negative 3 are zeros, use the backwards box method to factor s of x. So first I have an x plus 1. This one's x to the 4th, so I'm going to need more columns. So let's go ahead and put x to the 4th here. This is going to be an x cubed, so x cubed. My x cubed diagonal should be 4x cubed, so this one's going to be 3x cubed, because they've got to make this together. 1 and 3 would be 4. When I divide that out, let's see. Oh, shoot. If 1 is a 0, this would be an x minus 1. So this is going to have to be different, isn't it? So then this is a minus, so this is going to be 5x cubed. Negative 1 plus 5 would make 4. So now I divide that out, 5x squared. So negative 5x squared. So now this needs to make negative 2x squared, so I have to have a positive 3x squared. So 3x, negative 3x, needs to make a negative 12, so negative 9x, negative 9, positive 9. So now that I've divided that out, now I'm looking at this one, and this is what I've got to divide. And I'm going to be dividing by x plus 3 this time. So I take my reduced polynomial and I divide it. I don't go back to my original polynomial. Every time I divide, I reduce my power of x. So I start with x cubed, x into x cubed, x squared times. This is 3x squared. I need it to make a 5x squared, so this needs to be 2x squared. 3 plus 2 would give me back the 5. X into 2x squared, 2x times 3 is 6x. This is a negative 3x. And it works. Oh, this shouldn't be x right here though, should it? Let's go ahead and cross that out. All right, so I am now left with x squared plus 2x minus 3. Go ahead and factor it. Okay, so what are all my intercepts here? My intercepts are the 1, 0, the negative 3, 0. This one makes another negative 3, 0. So that one happens twice. That means it's squared, so I'm going to bounce. The next one, x minus 1, that's a 1, 0. So that means the 1, 0 happens twice, so it's going to bounce. So really, if I was writing out s of x, I would write s of x is x plus 3 squared times x minus 1 squared. So both of them happen twice. So we bounce. My multiplicity is 2. My y-intercept, well, my original constant term was this positive 9 up here. So it's going to be 0, 9. I'm looking at an x to the 4th, so degree 4 and positive. So this is my graph shape. And now I just need to go ahead and graph it. So here's my 1, 0. Here's my negative 3, 0. Here's my 0, 9. So I'm going to come down through this point. Or actually not through it, just bounce. And come back up and bounce. And both ends of my graph are going up, so y is always approaching positive infinity on the left and on the right. This one was definitely a lot trickier. I really like, though, this way that we had to take and keep dividing that same polynomial. We had to divide it. We had to take that answer. We had to divide again. All right. This is just kind of putting everything together, putting together the dividing or factoring part with the graphing part. As always, if you need help, please ask.